Okay, everyone, we now continue with our exercise for the linearization of nonlinear data set. So an experiment is conducted and the following data set is listed. It is known that y equals to x divided by a by x plus b is the best fit for the given data set. Describe that curve. This is the question. So it's again written here, the best fit, but the saturation function is given to you. But do not forget, guys, in this question I gave here the saturation function is the best approximation to that data set. But if you don't have any case, what will we do then? We will discuss in the next exercise. So here is the list is given to you like the experiment data results. So, and as you know, in previous we have discussed that how we linearize this curve. So we are considering here our expression as by considering the linearized curve, the version, and we have discussed here our linearized version. After linearization, we have the new variables as given in the follows. So, in previous, we have also discussed the expression like, guys, as I said, you please construct a table. This should be better for you. We will continue with this construction by creating a table, but do not forget, guys, from after the linearization, from now on, your matrix is corresponding to A big X plus big B is equal to big Y. So, by considering this linearized, this is the straight line from now on. For this reason, you should continue with here summation of big X square, summation of big X, summation of big X, summation of 1. This is valid for big X and big Y's, okay? Here is A, B, they are unknown for you. And then the right side will be big X times big Y, and here is big Y. So you will deal with your big X and big Y case, okay? For this reason, you should write down here your table by construction. You don't deal with the summation of X and summation of Y. You are dealing with big X, big Y, big X squared, big X, Y time, X times Y version. So I'm generally advise here again, even though your X or Y will be same as your previous small X or Y, you should write down here your big X, even though they are same, okay? But here they are not same, so my big X will be big over small x, Y is big over, 1 over small y. So here I'm writing from now on, just creating here 1 over x version. Point-wise division we are doing, and taken here the square version of my big X. Do not forget this big X. Because of this I'm writing in blue marker. And then create here big Y and big X times big Y. So I multiply by 0.1 times 0.5263. Okay. In our calculations, guys, generally we taken here 4 decimal points after, 4 digits after the decimal point. For this reason, you are seeing here 4 digits after these points, okay? And you know, I will substitute here all the summation of big, but do not forget. So we are considering here big X squared is the summation of which is given like we did in previous. So I'm writing here as last column as the summation of the data points. So from now on, we just substitute them. I am writing here A1 and A0, so this is corresponding to big A1, big A or big B, does not matter whatever you use here. So finally, guys, you are getting here the curve, like after doing the calculation, you will get the curve as you can see in the final decision. You should write your curve because your purpose is to describe your that curve. Okay, do not forget it. Okay, now one more exercise here. As I said you, if you don't know, if it is not stated in the question, this is the best curve, or it is known that the blah 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 is the best fit for that data set. So what then we will do? Actually, guys, this is replying here, this question, this answer, I'm giving here, the upcoming answer is replying your experimental study from now on. Okay, so because in the life, anybody cannot say to you it is the best fit to our curve. So you should describe which one is the best curve for you. For this reason, I'm having here a list which is given like the table. So I will define here, we are plotting it. I plot it in MATLAB by describing here x values and y values. From up to now, maybe some of you, some of the students can know how they can sketch here on a program. But if you don't know, next week or maybe 2 weeks later, I will do a tutorial session for MATLAB. Just MATLAB we will do. For this reason, this should be better for your calculation. Maybe next week is better, I think. For this reason, we will start to see here how we plot or how we can use here the regression part in our calculations. So here is the, I have sketched it, and I'm realized that here, I have realized that this curve is like you can see here, like an exponential curve. For this reason, I'm choosing generally exponential curve to approximate to that data set, okay? But I'm writing here exponential like exponential we are saying, but we don't know what is it. For this reason, I should define here the general approximation. There can be some constant times exponential dx form. Okay, so we have already discussed it in previous. We have discussed it for the linearization part. So I'm just writing here again the linear version, but do not forget it. This is like capital Y. We have defined here, this is your capital Y is ln small y. Capital X is the same like your small x. And A0 is described as ln C, and A1 is B. So as I said in previous exercise, please be careful when you are writing, even though your big X or big Y give rise to here small x or small y, which are same with your previous answers, previous data points. Please open another box, open another column to discuss it. Okay, so even though it is right as the similar to is the same as my small data points, I'm sketching here my one more column, adding here one more column by copying and pasting my data points here, because I am confusing in my calculation. If I otherwise is stated, without writing it, I can confuse. For this reason, to minimize my errors in my calculations, for this reason I'm writing my columns as you can see here. Okay, finally, big Y is ln y, so I'm taking here all the logarithm of my y column, and here is big X is the similar as my small x values. So big X squared here you can see, and big X times big Y. So finally, we are writing here in the square version, and we will read down here A1 and A0. Totally, we have seen here my our polynomial, which is best fit to our data. Okay guys, it is over for the least square approximation. So I have completed all the session of the interpolation for the least square approximation, but one is remaining for us, one interpolation, which is calling spline. So I will give also the linear spline case, but we are skipping here cubic spline or Hermite cubic spline. We have here a lot of things actually for the expressions. So this is our last topic for the interpolation. The linear spline, guys, means that here when you are using the spline approach, it is actually using the piecewise polynomials. So you will split your points, data points, step by step. So you're dividing intervals, for instance, and you are dealing with which curve will be the best curve for my approximation, or just using here the using 2 points in your data set, and you are using here the linear approximation. So the linear spline, the basis of the linear spline is passing through Lagrange interpolation. It's very actually the same thing, just you use here 2 points, okay? Especially there's no more point for your data set, just 2 points. Between these 2 points in your data set, you are using respectively 2 points, and you are creating here Lagrange interpolation. Okay, so the piecewise polynomial I'm defining, we are writing here S1I. It means that this is your I defines you here, the point that you chosen in your data set, and here 1 defines you the degree of your supply. Okay, so here is the exercise to understand it, because guys, as I said you, the basis of linear spline passing through the Lagrange interpolation, so you have also familiar to use it. For this reason, I'm just giving here an exercise. Okay, construct the linear spline interpolating the data. The values are given to you. Even though I'm having here 3 points, because we are choosing here the linear spline, so you will benefit from 2, 2. Okay, so you are choosing 2 points to create here your splines. So you will have here 2 different spline points, spline values actually, whose degrees are 1. So you will continue with, if your point that you are choosing here, if your point between your x0 and x1, you should use this formalization. And if your point here between x1 and x2, then you should use this value. Okay? So from here, guys, you are creating your spline polynomial by using x1 is 0, x0 is minus 1, y0 is 0, y1 is 1. By substituting them into the expression, and one can obtain here your polynomial, which is your linear spline polynomial. Okay, everybody. Now we have completed the interpolation title. Okay, so it is over. We have learned here in this concept is, we have learned that Lagrange interpolation by considering n plus 1 points, which gives me at most n degree polynomial. And continue Newton divided difference interpolation. We have learned that this concept by considering the derivative, because it consists of the Newton expression, so all the time it is dealing with the derivative. So to discuss the derivative, we are creating here like a tree, okay, in our table, and just writing here forward and backward option. We have also central option, but we have discussed just forward and backward versions. Maybe backward, I couldn't remember really. So after completing the Newton divided difference interpolation, we have discussed the least square approximation, which is calling regression also. To do this, we are mainly consider of the linear regression, first of all, to understand the theory behind it. And then we discussed, what if our data set has the nonlinear behavior? Then what will we do? And for this reason, we are trying to learn here the linearization process, okay? Converting your system into linear form, and you will follow it. And after completing the nonlinear data set, linearization of the nonlinear data set, we have also learned that linear spline. I gave it this concept for because of the later maybe you can deal with in your graduate finite elements method, which takes the basis as the linear splines. So we will see in the next week, okay, and we will continue with maybe MATLAB, maybe our new topic. I'm not sure about it, but I think probably we will discuss MATLAB. See you next week.